Hello there, Charger people. It's Mrs. Boyd here. We're going to talk today about the area of regular polygons. First, we need to look at a little vocabulary. This is pretty much without a doubt my favorite word to say related to geometry. It is this word right here, and we say it apothum. I feel like it's opossum, but not really. Apothum. It's pretty fantastic. An apothum is the segment connecting the center of a regular polygon to the opposite side at a right angle. So on the triangle, our apothum is going to come from the center and intersect the opposite side and make a right angle. On the square, comes from the center, intersects the opposite side at a right angle. With the pentagon, comes from the center, intersects with the opposite side at a right angle. That is an apothum. The area of a regular polygon is 1/2 times A, which little a is the apothum, times P, where P is the perimeter. So P, oh Lord, what have I done here? P is perimeter. So it's going to take us a handful of steps to figure this out, but we can totally get it. We want to know the area of this pentagon. So we're going to need the length of the apothum and the perimeter. Well, the perimeter is just the sum of the sides. So that is 50 in this case. We want to know the length of the apothum. I don't know what it is. So we're going to draw the apothum here. That's a right angle. And we're going to call that little a. So the apothum that I've drawn, I have drawn it to purposefully split the length of this side of the pentagon in half. So each of these parts is 5. Now, I can draw a line from the vertex to the center of my pentagon. That gives us a triangle. Now, I know one side of a triangle. I know it's a right triangle. If I can find the measure of either of these two angles, I'll be able to use what we know about trigonometry to find the other sides. So there's a formula for finding the measure of the central angle of a regular polygon. So the central angle of a regular polygon is made by an angle that comes from 2 consecutive vertices of a polygon. So this red one that I've drawn, and then another red one that comes at any of the nearby vertices. So I could have chosen this one or this one. It would have given me the same measure or the same angle. So this is a central angle. I can find the measure of this central angle by taking 360 divided by the number of sides. And that's, we'll call it CA, central angle. So in this case, this is a pentagon. So we'll do 360 divided by 5 and get 72. Well, just like I've drawn my apothum in such a way that it splits the opposite side an exact half, I also have drawn the apothum in such a way, same way, that has split this angle exactly in half. So if this angle is 72, this side of the angle is half of that, which is 36, is that measure of that angle. So I need the length of the apothum. I have a reference angle here, and I know another side of my triangle. So let's label these. 5 is my opposite side. The hypotenuse is always across from the right angle, and that means the apothem is my adjacent angle. I know that this angle is 36. I have opposite and adjacent, so ka, toa, oa is opposite and adjacent. That means I'm going to use tangent. So tangent, my angle measure is 36. I'll be using opposite over adjacent. So the tangent of 36 is 5 over the length of the apothem. We're going to multiply both sides by a, and I get a times the tangent of 36 is 5. That means I can divide both sides by the tangent of 36, and I get a is 5 over the tangent of 36. If I put this into my calculator, I get that A is 6.8819 or so. Now, I have everything I need to find the area of this pentagon. I know the area is equal to 1/2 times the perimeter, which we know is 50, times the length of the apothem, which is 6.8819. I multiply these together, and I get the area is 172.0 units squared. Remember that the area is always in units. All right, so a handful of steps to find this. We can totally do it. We know what we're doing. We're going to make it happen. Oh, Lordy B. There we go. Let's try another one. We have this triangle that's a regular polygon, a regular triangle. We draw an apothem right here, and we'll call that A. If this length is 10 of this length is 10 of our triangle, that means that half is 5. So each of those sides is 5. I know I can also draw an angle like this to represent our central angle. I can find that measure by taking 360 divided by the number of sides. So that's 120. I divide that by 2 to get the measure of the half inside my triangle, and I see that that angle is 60. Now I need to see what I need to know. I've got angle 60, 5 again is opposite, apothem is adjacent, hypotenuse is what it is. So again, I can use the tangent of 60 is 5 over A. I know from my last endeavor with tangent above and from other times that we've done it, I can multiply by A and then divide by tan of 60. What that boils down to is I trade tangent of 60 and A spots and rewrite it pretty much like that. I put this in my calculator, and I get that A is equal to 2.887. So our apothem is just shy of 3 units long. I also need the perimeter. The perimeter is 3 times 10, which is 30. And now I have everything I need to find the area. 1/2 the length of the apothem and the perimeter. And that means our area is 43.3 units squared. Okay, let's flip it over to the back side. Do some more practice. Find the area of each of these, excuse me, regular polygons. Here, know the length of the apothem, or know the length of the apothem. I don't know the length of the side of the polygon, and I don't know I do know the central angle of my pentagon. 360 divided by 5 gives me 72. And then I divide that by 2 to get 36. So this angle's 36. I need to know X so that I can find the perimeter. So we will do the labeling of our sides. We know that X is on the opposite, 4 is adjacent. The tangent of 36 is X over 4. I can multiply both sides by 4. And I've got the 4 times the tangent of 36 is X. I put that business in my calculator. And I get X is 2.906 or so. So if that's just X and I want the length of the whole side, I multiply that by 2. And that means my side length is 5.812. So I need the perimeter. If I can get the computer to work. There we go. The perimeter of my pentagon will be the length of the side times 5. And that's 29.0617. My area is 1/2 the apothem length times the perimeter. And I get my area to be 58.12 units squared. Let's try another one. This one's a little bit more exciting. My apothem length is 2 times the square root of 3. I don't know the length of the side. I can find the length of my central angle though. I've got 6 sides, so we do 360 divided by 6. That's 60, divide that by 2, and I get 30 for my angle measure. I don't know the length of the opposite side as I would need to, but this is a 30, 60, 90 right triangle, and I know the long leg length. So I can use that and what I know about 30, 60, 90 right triangles to find the length of the short leg, or X. If I have a long leg and I want a short leg, I divide by the square root of 3. Square root of 3's cancel, and I'm left with X is 2. That means the whole side is 4. And for the perimeter, we do 4 times 6. That's 24 units. So now we have everything we need to figure this out. The area is 1/2 the length of the apothem times the perimeter. That means our area is 41.60 units squared. Sorry, that 6 is crazy. I changed my mind about the answer mid-writing. All right, one more, and then I'm going to unleash you to your own devices. Got an apothem here that I'm going to hook up with that right angle. I know the side length is 6, so that means the bottom of the triangle is 3, the short leg there. I can find the central angle. It's the same as before, 30 degrees. Oh, just kidding. This is an octagon. It's got 8 sides. So we do 360 divided by 8. And get 45. Divide that by 2. And it's 22.5 for that angle. Can't really read that, so we're just going to erase. Don't know the length of the apothem, so we're going to have to figure that out. Again, it's the tangent tangent of 22.5 is 3 over a. Like we did before, we're just kind of going to swap them out and get the a is equal to 3 divided by the tangent of 22.5. And we get that a is equal to 7.243. Our perimeter we can find pretty easily. We do 8 times 6, that's 48 units. And now we have what we need to find the area. The area is 1/2 times the perimeter times the length of the apothem. Put that in the calculator. And our area is 173.82 units squared. I hope this is pretty clear for you. I know it's lots of steps, but I think with some practice, you'll be just great. If you have any questions, let me know. I hope to hear from you soon.